Okay, you were live.
Awesome. Let me pull up my screen share quickly. There's going to be some back and forth on some screens, so just bear with me for a moment. I'm going to move this stuff out of here. Right. So let me know. I'm going to go into presenter mode. No issues here.
Seems fine. I can see it fine.
Perfect. Awesome. All right. We're ready to go 2 minutes after the hour. So thanks everyone for coming. My name is Matt Nelson. I work at Consensus and I'm a product manager for the Consensus teams that help develop Hyperledger Besu. So I know you're probably all familiar with Besu. If you're here, the topic of today's workshop, we're going to go through basically where is Besu after the merge? How did the merge impact client development? And then, how does that allow you to basically get involved with public networks? We think now that the merge is completed and we switched to proof of stake, that there'll be hopefully a lot more interest in developing on public networks. So I'm going to talk about kind of what that means from the perspective of running and operating a node on public networks using Besu, connecting to your Besu RPC to do different tests on things like smart contract development. I'll just skip to my agenda slide, which actually goes into this in detail here. So again, we're going to be talking about the merge. I'll do a quick overview of the narrative. I won't get too deep into this unless there are specific questions, because I'm sure that a lot of the folks are familiar or heard some of the other talks that I or others have given around this, but specifically how it's impacting Besu. I'm going to talk about Besu in the context of staking and validating in the Ethereum public network. And then I'm going to talk through kind of a more technical part of the workshop. My intention is not to necessarily have you follow along right this moment, just because syncing nodes is, frankly, it takes a few hours to do. So there's no point for us to really sit on the call while that happens. I have nodes in sync and I have nodes that I'm going to spin up live to show you kind of both sides of what that looks like, and how to connect to the networks and kind of how easy it is really to connect and work with public Ethereum networks. I'm also going to talk to you about how to connect wallets, test dApps, test your own applications that you might be developing, and how you can even potentially kind of create public-ish testnets among your own nodes, depending on what computing resources you have available. And then I'm going to talk about development environments really quickly, but mostly that's kind of a next steps thing. I'm going to just gloss through what that looks like on how you can continue smart contract development if that's what you're interested in. But mostly I'm going to focus on 2 through 4 today. So whoops, I'm going the wrong direction actually. Before we get started here, I also wanted to talk to Besu as an open source client and how we are actively looking for contributors. So I know that folks, we are active in our Discord, learning and kind of testing things out, going through node infrastructure, kind of learning the do's and the don'ts here. But frankly, we are actively looking for contributors. We want you, right? Why do you want to get involved with development of Hyperledger Besu? One, you can shape the direction of the project. We want to make sure that what we're doing is valuable. We are focusing in this instance on public networks, but we want Java developers of all skills, all types, looking at all use cases to really make Besu the best client that we can have. On the contrary to that is that Besu is now makes up roughly 10+% of the Ethereum network on public mainnet. So we kind of have a duty to the network to do really the best work that we can. So we're always looking for new engineers to help smooth out some of the edges on Besu. Of course, you'd help us decrease time to market and accelerate the work of the project. You will be able to be a part of the community and leverage others and leverage, tons of people to get logs, to get information, to help develop the client in the way that you're seeing fit. So we're really looking to engage more community users. Frankly, we've had a huge influx of users in relation to the merge, and it's becoming very hard for organizations like Consensus to work with all these different folks. So we're always looking for new people to get involved, whether that's just from like a community engagement perspective or literally developing against this. We love to see more people get involved here to help fix bugs. And you'll learn a lot, not only from running nodes, from working with community members, but you get to work with developers who've been building Besu from the very beginning, and learn a lot about the software engineering from the perspective of blockchain protocol engineering, which is very, very unique and very, very challenging in some areas, but there are a lot of good issues that, first issues to get there. Of course, you'll gain experience that'll be great on a resume for Web3 jobs, blockchain jobs, software engineering, really getting your hands wet on open source development. And of course, we have a worldwide group of people who are interested and want to help. So participating in an open source community is very valuable. Another plug is that if you work on mainnet focused things for Hyperledger Besu, you can literally be paid for that work by the protocol guilds. There are a number of grants and incentives being run by organizations like the Ethereum Foundation. So if you work on Hyperledger Besu and you improve it in the perspective of mainnet development, you can be paid as a part of those programs. So I encourage you, I'm not going to do too much of a plug here because, we are independent of that program. It's not necessarily related here, but there are incentive programs being run that will potentially pay out contributors. So definitely worthwhile looking at that. If you already have the skills and the time, I would encourage you to look up some of those, and you can email me. My emails are on the slides, and we can, or chat on Discord, whatever. We can talk more about what that specifically looks like if there's interest there. Last things is, don't wait for an invitation. Open a PR. Like, you can fork Besu and open some PRs. Like, people will. There's nothing too small. I make PRs for like logging changes all the time, like one-liners. Feel free to lurk. Check out our channels on Discord. Check out the wiki pages. There's a lot of good information there. And just, however you think you want to get involved, we welcome all of it. So feel free to message me, email me, or David as well. David created these slides and has a lot of, good background on the Hyperledger Foundation. So he can help you get plugged in if you'd like as well. I'm going to gloss over this, but basically, we use GitHub for managing the Besu repository. We have a wiki for proposals and for kind of other information that we share. And we use a lot of Discord for our chat. So use these tools, check them out. Here's some links. I'm going to share the slides after, so don't worry about collecting all these links because there's a ton of links throughout the whole thing. But there's a bunch of stuff here that's really good. Good first issues tag on GitHub also. Those are some small changes that, like I said, can get you rewarded and get your hands dirty on Besu. That'll be really useful for everyone. All right, so I'm going to dive right into it now. So the merge and Besu, right? First of all, what is the merge and is it trying to accomplish? So I kind of want to give some background before I dive into the technical specifics. But the merge, which happened about 2.5 weeks ago, was intended to build a more sustainable ecosystem around Ethereum public networks that is more secure and very much so carbon efficient compared to the previous iteration in proof of work. The goal of the merge was also to create a bigger diversity of clients and a bigger decentralization vector by removing the hardware requirements to run validating nodes. So previously you would need very intensive mining hardware. Now you just need the ability to run moderately powered virtual machines, or, Besu can run on, machines with reasonable amounts of RAM and memory. So the requirements have gone down a lot. Yes, you still need to stake ETH, but there are many technologies that allow that 32 magic number to be brought down a lot lower. So there's really, openness of participation in proof of stake, which we're really looking forward to. And it's helped Besu grow dramatically as a client, and, is really helping the decentralization of the network and the security of it. It's much more expensive to attack Ethereum now. Energy efficiency, the second key tenet, this is really what it's all about, the kind of reason to be for the merge, removing the proof of work mechanism for consensus, bringing in the proof of stake mechanism for consensus, and eliminating 99.9% of Ethereum's carbon usage overnight, which is many to believe is the largest reduction of carbon by any technology in human history, which is quite exciting. Although when you contrast that against the fact that proof of work was horribly wasteful, it's not so great, but hey, we got to make incremental progress here. The third is about transitioning. Basically, the developer experience is exactly the same before and after the merge. We worked hard to make sure that the technology worked in the same way. I'll explain more what this means when I talk about Besu as basically a part of this tech stack. But in reality, a lot of hard work was made to ensure that the technology would remain the same before and after, that a lot of the APIs and a lot of the connection points and a lot of the smart contracts would not have to change. And there's very, very little that actually changed. So this was really a resounding victory for developers and for people in the ecosystem to not have to rebuild. And it just signals kind of more about what proof of stake has to offer going forward. Last is the economic model update. I won't dive too deeply into this, but basically the economic model of Ethereum has changed. This correlates to reduction of issuance of Ether, changes to the fluctuation of supply, and like I mentioned, a security model change where the 51% needed to control the network is much more than hash power. It becomes a monetary incentive, which is in the billions and billions of dollars at this point. So if there's questions at the end, we can go deep into that, but I will kind of pause on that one for now. What does this mean as far as technology is concerned? So I know you've all probably heard, but the reason it's called the merge was because we initially had the proof of work chain in Ethereum. We had the kind of beacon chain, which was running separately, but not actually performing consensus for Ethereum mainnet. We merged those two chains together by signaling a transition where these two pieces of software that were previously independent, so Ethereum 1 software like Besu, and consensus layer software. And in this example, in today's workshop, I'm going to use Teku as our example. But the merge basically signaled those two pieces of software to work in tandem to run consensus for the network. This is a oversimplification, but essentially new sets of APIs were created to allow the execution clients like Besu, like Geth, like Nethermind, like these execution clients to speak with the consensus clients and to allow them to steer the ship and to secure the network. But the execution of smart contracts and transactions still happens in the kind of ETH1 layer, or now it's called the execution layer. The reason for this is because these ETH1 clients, execution clients, were good at what they did. We didn't need to throw them away. We didn't need to change what they did or create kind of a new Frankenstein monster. We simply remove the portion of the code where they, or shut off rather, the portions of the code where the execution clients handle consensus, and we've shifted that over to a new client. So the new stack in proof of stake Ethereum is 2 clients, and there are many combinations, and they all interoperate based on something called the engine API. I'm going to get into this a little more in some later slides, but basically you need 2 things. Previously you needed 1, and the gains are all in the carbon efficiency side. And scale was not the focus of the merge. Scaling will come later on / now from things like rollups and sharding. I encourage you to kind of do the research on those, but essentially we have other technologies to address scale and data availability problems that are coming down the pike now and are already, layer 2s are already gobbling up a lot of the transaction volume on Ethereum mainnet, which is only a good thing because it's driving the price of gas way, way down, and it's really increasing participation in the network. But all the good security guarantees come from these 2 things, these consensus and execution clients. So proof of stake merged. Now we kind of have this one thing, and we're adding on new technologies now that the merge is complete to work on scaling and data availability and other problems that we have in the protocol right now. Whoops. Quick merge timeline. I'm really not going to get too deep into this, but the beacon chain was launched quite a while ago. The staking deposit contract around 2020. So we've had this launched on mainnet for about 2 years. A lot of hard forks in there, a lot of interesting development, but this is kind of how protracted the timeline came up at the end, where we had 1, 2, 3. Well, so the Robson, Sepolia, and Gurley merge, 3 test merges. Test net merges, and then we had the big event in September of 2022. There's more information at this link here if you're interested in diving into the timeline, but it's been a long journey to kind of figure this out. Now, how does this impact Besu? It really comes down to the fact that Besu is no longer a do-it-all kind of client in terms of Ethereum proof of stake. When it comes to other consensus mechanisms like proof of authority or private network consensus mechanisms, Besu remains largely unchanged in that sense. Proof of work is also still available within Besu to support networks like Ethereum Classic. But in terms of Ethereum proof of stake, we've changed the way that the code operates to, like I said, use this engine API to communicate between any number of consensus clients and the execution client, in this case, Besu. So Teku, I've included here as kind of a little logo, is one of the consensus clients, but there's multiple others. There's Nimbus, Lighthouse, Lodestar, Prism. There's a diversity of clients, and they all are spec'd against the same engine API standard to ensure interoperability. And that's the same on the execution client side. The networking stack remains largely the same. The RPC like the JSON RPC API remains largely the same. So developers who've built tooling around Besu, around RPC, and around these APIs, they don't need to change their approach. Instead, they get more APIs via the consensus layer REST API. And basically, there are some new endpoints on the execution side, which give us more data, but it's largely unchanged. And again, the reason for that is because we wanted the developer experience to remain the same. We didn't want to have to throw away infrastructure, and we wanted to be able to have clients that already exist in private networks, consortium networks, side chains, what have you. These will continue to be compatible with Ethereum mainnet due to the fact that the execution client remains basically the same in both of those capacities. So this was done intentionally to keep compatibility, at least on the Besu side, with private networks and mainnet, and have those standards allow the things to cross those boundaries, which is pretty awesome in my opinion. Yeah, like it all comes down to, what does this mean for enterprise? What does this mean for users? Besu is an execution client now, but public network participation is rewarding, right? You can literally be paid to secure the network. You can learn to operate node infrastructure. You can secure the network by staking and engage new communities of developers and users. This is a pretty big kind of lure here, that the staking rewards are roughly around 12% now. That number is going to go down. These are annual returns, rather. These numbers will go down as more validators enter the network. But with things like MEV and some of the other innovations, the staking rewards are pretty high right now. And I think that the time to learn and to understand what this means for different enterprises who are interested in Ethereum is now, because the network is just getting used to proof of stake. It's running successfully and things are working, but the infrastructure is still a little bit fresh, and there are a lot of things to understand before staking that I think would be good for public network participants to know. And we're going to, of course, dive into a lot of that today. And it's a new opportunity now that Ethereum is sustainable and it's scaling and it's open for business, right? You don't have to worry about deploying new applications on public infrastructure, because there's no more kind of carbon boogeyman over the shoulder of any business that tries to deploy NFTs, for example, or things onto Ethereum mainnet, because that has been totally removed. So I think the barriers to entry are much, much lower to building on public infrastructure. And I think that this is only a good thing to encourage more people to not set up costly infrastructure and to think through, how do I engage public network users? How do I engage, liquidity on these networks that already exists? New use cases, kind of new paradigms, without having to, throw away. I already have a knowledge of Besu. I don't need to throw that away. I already have infrastructure potentially in place. And all I need to do is learn how to operate this kind of new stack in a way that makes sense, and to learn some of the opportunities that are in the space. But I believe, now that the merge especially has been completed, I think enterprises can feel secure in participating in public networks. Again, there's a lot of nuance to what the actual smart contract development looks like, but we won't touch too much on that. But from an infrastructure perspective, I wholly feel this is the case. And I think that now is the time to start looking at, what data can we pull from the network? What apps can we deploy? What, new business models can we try out? Things like that. So that long-winded intro, I'll pause for a hot second. If there are any questions in the chat, I see we have some questions around the EVM and zero knowledge EVM. So quickly, this is a little bit of a kind of off topic, but I appreciate the question. Zero knowledge proofs and zero knowledge EVM, we are actively looking at what that looks like for Besu. So we are, like I said, I'll get into this actually as we get to the slide after this one, but we are actively looking at expanding the picture around Besu execution to include more than just Ethereum public networks, more than just Ethereum mainnet, but to be EVM based public networks. And that means a lot of things, but in reality, what it means is that we're tailoring, we're going to continue to build off these. I'll get there when we get to the slide, but anyway, to reiterate, why is participation rewarding from a staking perspective? Currently 5.2% APR here. That's a pretty big number. Post-merge, we're seeing a little bit more now that block rewards are involved, up to around 12%. With MEV, which I won't touch on, there's essentially additional software you can add on to get even more value. It could be more than like 12%. But yeah, these things are it's valuable, right? Depending on the size of your stake, there's money to be made and there's a lot to be learned here. And soon there will be the ability to withdraw it on stake. We think that, a lot of people think that that might actually remove the need to stake on the Beacon chain, but I think on the contrary, it's going to bring more validators online because they have the ability to enter and exit at will, which I think we'll see more participation as people become less burdened essentially by the process here. But these rewards are large. There's the potential, so the first proof of stake block that was mined had a very, very high miner tip of 43 ETH. So somebody made probably around $50,000 mining that first proof of stake block because of these essentially tips and fees. I won't talk too much about how that works, but it depending on the block that you mine, these things can be very lucrative. So these are the average kind of aggregated rewards. I won't dive too much into that, but there's a lot more information out there. I'm actually going to come back to this slide after I go here. So Besu's architecture as it is today, right? We have a whole mess of components, a whole mess of things that are going on. We have an interface layer here at the top, which interacts with your dApp or your wallet. So this is MetaMask. This is a specific application. This is any other wallet that you might use. And then again, we have the engine API built on top of that kind of RPC layer used to connect to that proof of stake consensus client. So at the bottom, we have our traditional Besu fund stuff. We have our world state storage. So this is really key because in the new proof of stake stack, the execution client still handles a lot of the state, especially historical state. So they keep track of what is up with the accounts, what's up with the codes, what's going on in the trie. So like basically the actual blockchain itself and the kind of the trie nodes that connect everything together. And then the overall picture of the blockchain itself. So those finalized blocks, headers, other information. And then, of course, we have our networking layer. We have the execution core, which is kind of the really key piece here with the EVM at the center, so the Ethereum virtual machine. And then we have, of course, things like the transaction pool, synchronizers for the differences in the way that things come in, and the block validators, which make sure that transactions are valid before they are put onto the chain. To the previous question about zero knowledge and other EVM-based chains, our goal is to the EVM is currently decoupled in Besu. And what that means is you can extract the EVM and not use all of these other components. We want to kind of change that up a little bit further to be, the EVM is kind of using the execution APIs, these engine APIs, to do a whole bunch of cool stuff. We haven't fully baked this out yet. We're focusing on a lot of post-merge bugs. That essentially means exposing execution of the EVM to other network types, other, prover types. So like zero knowledge EVMs, pluggable EVMs, different kinds of approaches that'll allow us to support other chains like, Gnosis chain, or different services like Oracle services like Chainlink, or even layer 2s like Arbitrum and Optimism, because they all use slightly tweaked versions of these core codes. And we're going to lean into that as kind of a modular Besu architecture that we're looking to continue to build out. But of course, this is the point in time snapshot view. And I'll have more if you're interested in that topic that I'm discussing right now, check out the talk that I did at Global Forum, at Hyperledger Global Forum. It explains in detail exactly what we're discussing here, which is basically what is the future of Besu as an execution engine. So I would definitely encourage you to go check out that talk. It talks a lot about the decoupled EVM and the execution engine APIs and all this good stuff. So yeah, I got a question about explaining staking rewards in a little more detail. So I'd absolutely love to do that. Basically, when you stake ETH, there are two things that can give you rewards, and there are two things that can kind of take those rewards away. So I'll start with the things that give you rewards. So in the proof of stake world, your node has responsibilities to witness and attest to other transactions that are put into the blockchain by other users. And your validating node is also responsible for building blocks when it's your turn. And when it's your turn is basically random chance. So they do rounds of voting and they move things around, kind of round robin, random style. And when it's my turn to propose a block, I put that block up. The network votes on it. And if it's correct and has all the right things, I get all of the individual transaction tips that go into that block. The economics of that are determined by something called EIP 1559, but the basic is people can pay more money to have their transactions gain larger priority, and those tips go directly to the validators. So if I build a block that's filled with big tips, I get a lot of money for that block. And since block production is relatively small in this case, the chance that I produce a block is somewhat smaller. Those rewards are a lot higher. So the attestations are much more constant and much more smaller stream of rewards, because my node is just witnessing and voting on what's happening in proof of stake to ensure the chain can progress correctly. But when it's my turn to propose a block, that's when you kind of get the big bucks. And if you amortize and like average those rewards, this is where we get these numbers. But it really depends, right? If someone, like I said, pays in one specific block and you get really lucky for a huge tip because they really want to maybe they really want to mint an NFT and they want to be the first person to mint that NFT, they can pay a huge tip to get their block or their transaction included in the next block. And if you just happen to be the person that proposes that block, you get to take the entirety of that tip. That's how, like I mentioned, the 43 ETH block reward was mined on that first proof of stake block because people wanted the kind of the notoriety of mining the first proof of stake block. So a lot of different users, whomever, put up big tips to get that block to have their transactions. So that's obviously an edge and kind of extenuating circumstance, but it really depends. Like these rewards can be quite high, there's the steady stream of rewards, and then there's kind of the big blips of rewards that bring you to this number. On the contrary, the two the two penalties that can be incurred are basically slashing and penalties. So penalties is the wrong word. The two instances where you can lose stake are penalties and slashing. Penalties are very much so penalties, right? They're not big, that you're not screwing up. You're just potentially, like, going offline is a good example of a penalty. It's called an inactivity leak. If I go offline, I don't like lose all my ETH, but I basically miss out on those attestations. So I'm hit with the penalty that's roughly the same size. It's very small. The way that people like to view it is essentially you can, for the amount of time you spend offline, you can re-earn back those rewards just as long as you're online. So if I go offline for a day, my node, if I'm back online tomorrow and I run for 24 hours, I will have made back the amount that I lost roughly. So the inactivity penalty is really just made to keep people online and keep people validating, keeping the network decentralized and running smoothly, because we don't want the number of nodes to drop too low. But it's not meant to be like, oh, your power's out for a day or your internet goes down, you're totally screwed. That's not the case. These penalties are, again, they're roughly correlated to the amount of time that would take to re-earn them back online. However, slashing is much more dramatic. There are a few reasons to be slashed, but mostly it's intentionally nefarious. So if you're being an intentionally nefarious user, other users who witness that behavior can put up a proposal to slash your stake. So for example, if I'm running my validator keys in 2 locations, basically trying to double up on my rewards with 2 validators using the same stake, I can be found out and slashed for that behavior. And I will essentially lose a lot of my stake, half, potentially more, depending on how long that process takes. And you're also forcibly ejected from the network, meaning you cannot regain the rewards that you would have running a validator going forward. So slashing is intended to prevent the economic manipulation of the network. It's intended to take the stake of those who are trying to do that. And it's not intended to harm average users. So most people will not encounter this. Like there's slashing protection built into a lot of these consensus clients by default, because they know that you don't want to run your keys in 2 locations on purpose, right? Like, so if you accidentally deploy, a node that has 2 sets of keys attached to the same fee recipient in that way, like there'll be things that are like, don't do this. So as long as you're following the basic rules, for the most part, you are not going to be slashed. Okay, I got a question about how will the decoupling of the execution layer and the consensus layer impacts Besu's use for private and POA consensus networks? The answer is it really won't. The if I'm going to go back to let me try to find that. Yeah. So these privacy features and these pluggable consensus mechanisms, they're basically considered part of this consensus framework. In any attempts that we will make to kind of modularize the execution component, we'll keep the ability to plug in these consensus mechanisms, and we're not going to like throw it away or discard it. Our goal is to make Besu more kind of lean and modular for execution, which will frankly remove cruft and like unnecessary or vestigial code from private networks. Because as you kind of pick the Lego blocks you want to build a consortium network, you don't have to include all of the like proof of work or like public network stuff. So, we're hoping that it will streamline the release process for both and make it a lot easier to deploy exactly what you need and not have overhead from, say, I'm like, my node is trying to run public network stuff. But anyway, yeah, so that's that. I'll have more to share on that later. Like the Besu teams, we haven't decided necessarily on a way forward on this exactly quite yet. Our immediate goal is to clean up all of the merge code and make everything a lot more, robust. But again, we're going to continue to support these private network use cases, and the consensus layer should have no impact, because if you're running a private network, you don't need to talk to the consensus layer because you don't care about proof of stake. So that's the answer to that question. Can I talk a little bit about soulbound tokens? Soulbound tokens, which is another question from YouTube. I can do that super quickly. It's very off topic, but in reality, soulbound tokens are NFTs which cannot be moved. So for example, if I have a specific wallet address that's associated with me, and maybe I complete I go to university and I complete coursework, maybe my university can provide me a soulbound token that says I completed, 4 years of university, whatever, with this degree, what these data points, and that can never be transferred. So there's no risk of kind of like scams where maybe someone scams me and I click a link and it just automatically transfers the token. Like there's none of that, because these NFTs cannot be transferred. They're basically bound to the address to which they are issued. There are some like nuances to that, but that's why they're called soulbound. They're basically bound to the address that they end up on. Yeah, and there's for sure arguments about verifiable credentials, DIDs, and soulbound tokens. But again, that was an example for a question from YouTube. We can, if we really want to dive into it, we can do it more at the end. But yeah. So, okay, let's switch over to the kind of tech side of what I'm going to show today. So I'm going to quickly go through this slide on what are the things that you need to do to follow along and to get started. And then I will switch over directly to a tech demo, and we can go into that. As to low code, no code platforms, that I'm not sure. I presume that it depends on what you're trying to do. Besu is essentially infrastructure software. So I'm presuming that if you're trying to build applications on top of it, you would need low code, no code that targets Solidity and all that other stuff. But I would need to do more research there. Anyway, so to get started, there's a bunch of things to keep in mind. So these two on the right-hand side, or the left-hand side rather, these are the clients, right? I've chosen, again, Teku in this example. I work at Consensus. Consensus develops Teku. There are multiple other choices for Consensus Layer client, and they are all compatible with Besu. So there's no extra work that needs to be done in order to connect those things together. But I've provided links to the docs. There's docs specifically for connecting to a testnet, which is what I'm going to walk through today. So if you want to follow along directly for the tutorial, I encourage you to go to this docs page. It has breakdowns that will link you out to other areas of the docs. So if there's any areas where you have more questions, definitely stop me during the demo. But at the same time, the docs, this tutorial is in these docs, and they will have more robust, it'll push you in different directions of the Besu docs to get you what you need. Also link to the system requirements on the Teku and the Besu side. Let me throw the link to the docs page in the chat. That's a great idea, actually. How did I get this back now? Okay. Just to reiterate, everyone can still see my screen, correct? Yes, no, maybe so. Cool. I'm just going to guess that we are. Cool.
Yes, the answer is yes.
Perfect. Yeah. So I just dropped the link to that specific tutorial that I mentioned in the chat. System requirements, docs for Teku. 4 other tools that will help. These are not required, but the Postman collection in Besu is super helpful for hitting the RPC endpoints to determine things like how many peers do I have connected? Like what's my log level? Can I change that to get debug logs? Like there's a ton of stuff in this Postman collection that I'll walk through, but it's really easy to download and set up. And I'm sure that if you are a developer or a software engineer that you're familiar with Postman or at least the RPC APIs stuff. The Gurley Launchpad. So if you want to test a stake before you actually stake real ETH, which is 1000% recommended, do not stake ETH on mainnet without testing it first on a test net. You can go to the Gurley Launchpad. The Gurley Launchpad is basically run by the Ethereum Foundation. It connects you directly to the Gurley staking contract where you can stake 32 ETH, or in this case, testnet ETH. Also, ping me if you really want some Gurley ETH. I am a Gurley whale, and I will send you some to test this out. But anyway, it will there's, of course, thinking about staking, things to understand, and then it'll walk you through the actual exact process of, basically breaking down what I've talked about in a large part. And it will allow you to deposit directly to that testnet stuff. And it'll even, I am not a reliable Gurley faucet. Let's just say that. But there are, I can also link out to some Gurley faucets when I share the slides. I'll add in some faucets there. But yeah, I do have a lot of Gurley ETH. So if you're able to get, if you're looking to stake, I'll send you guys 32 ETH, 32 Gurley ETH. But anyway, yeah, I would 100% recommend reading the Launchpad. It is absolutely, you actually have to do it if you want to stake, but it really asks you a lot of questions on like what you are looking to accomplish. What is your staking setup? Do you have enough disk space? Do you have enough CPU? The Besu docs cover a lot of this as well, but this will let you know what you really need to be concerned about from the perspective of actually staking. So, a good place to go. Postman collection I mentioned. The MetaMask download, any wallet is allowed. I'm just going to use MetaMask in this demo, so no worries if you want to use something different. But for example, we have our MetaMask connected to localhost 8545, which is my running Besu node in the background. So it's really useful to be able to, one, connect it to see that your Besu node is providing you correct RPC, and 2, to make sure that you just you understand what's going on. You can see the ETH in your balance, check assets, and do whatever you need to do. So if you're not familiar with MetaMask, it's a wallet of any kind is relatively required when it comes to doing stuff with testing. And then also Grafana. So setting up metrics for your node. I'll show specifically what I mean and what the metrics are. There's a ton of metrics available. If you're a Besu infrastructure person, you've probably already seen this. So I'll go through everything. And if we need more detail on certain parts that I think people might be familiar with, we can just dive in there. And then there's also a Docker approach for the same thing. I'm going to be doing everything in this demo bare metal on macOS. The reason being is that it's just easier to demonstrate what's happening. But there are plenty of tutorials around Docker and around other environments as well. Everything should work relatively the same between Mac and Linux. As for Windows, there is support for Windows with Besu. There are some constraints when it comes to the cryptography libraries. And when I say constraints, I don't mean it won't work. I mean, you might have less optimal performance. But other than that, it's pretty much the same. But yeah, there's tons of information in the docs on that. Before we get into the demo, one more off-topic question. What does it mean that Hedera claims to use the Besu EVM? Does that mean we could host a node on Hedera using Besu? So Hedera uses essentially a custom implementation, or they like I said, they extract that Besu EVM into another environment where they hit the endpoints of the EVM with like essentially the same commands that would be needed for smart contracts, but the inputs come from the Hedera ledger. So different inputs, same execution environment as Ethereum. And then, the outputs are translated whichever way they need. So what that really means is it brings EVM compatibility to Hedera, because you take the chain inputs of the hash graph, you parse them in the way that makes sense to the EVM, you run the smart contracts in the Besu EVM environment, and then Besu will spit back out information that Hedera can understand and can change the state on Hedera. So it's really just using that EVM as kind of a state machine for Hedera. to run Solidity-based smart contracts. And the reason that is because, like I said, there's been a ton of good work done in the client to make the EVM extractable, meaning I don't need, this is actually a great segue to my diagram again. I don't need all of the other stuff to make it work. I just need this and some of these things. Like, so it's really just what inputs do I need? I have smart contract code, I get outputs. If I'm running on Ethereum, I get all this other stuff because that's just the way that it works. But again, we're looking to expand a lot on this topic. So if you have more questions on that, I really do encourage you to check out the YouTube that I gave for the Hyperledger Global Forum talk. And David, if you could maybe share that in the chat on YouTube and on Zoom, that would be great, just so people have it. Okay. Before I continue, let me pause for any burning questions on what I just discussed. We're going to spend the rest of the time going basically through my demos and stuff. I also want to take a drink of water here. All right, then I will just continue to answer questions as they come up. But I will, at this point in time, switch over to some of my other things. So I know this is a lot of gobbledygook. Where I'm actually going to start is the configuration files. I'm going to make this a little bit bigger for everyone to see. So I have 2 files open right now and 2 environments. So first I'm going to open my So again, for the purpose of proof of stake, you're going to need 2 clients. So in this case, I'm using Teku and Besu. You can learn where to download those and how to get them installed on your machine in that, like I mentioned in the links in the previous slides, but it's pretty straightforward to get this test set up. These things are a little bit heavyweight, so make sure you have, not heavyweight rather, but like they'll use a lot of memory. Make sure you have enough disk. I actually ran out of disk last night by accident when I was syncing this webinar. But I have it, it's all ready to go. You have these 2 nodes running in the background. And again, they run on bare metal, they run in Docker, however you want to do it. It really is pretty straightforward to set it up. All you need is 1 command and a config file. So to start Besu and connect it to Gurley and connect it to my consensus client, all I did was run this 1 command. And I pointed it to my config file, which is this Gurley config.toml that I'm going to walk through in just a second. It's dead simple. As long as you have your secrets and everything set up, the port stuff. But yeah, basically it's dead simple, and it's all based around these configuration files. So stuff you might be familiar with if you're running Besu. What's my log level? Fine. I'm at info. I don't want to spam you guys with logs while we sit here because it'll be impossible to read. Data path, basically a location to your directory. Easy, straightforward. This is where it's going to store your database. And again, make sure the drive that this is attached to has plenty of storage. Gurley is around 150 gigs or something like that, but mainnet is a lot more. So prepare to have about a terabyte free. I would say Besu on mainnet uses maybe 600 and something gigs. So you should, state will grow over time. Just make sure that you have plenty of memory available, both in RAM and in storage. I would recommend at least 16 gigs because you're going to need to run both Besu and Teku, 16 gigabytes of RAM. My machine has 32, which is great. I'm able to run the Zoom webinar and run 2 nodes in the background pretty much without breaking a sweat. So again, just RAM will be likely your constraint here, RAM and CPU. So make sure that if you have the ability to spec a machine, now that mining is gone, we don't care about GPU power really. I would focus again on the disk space, making sure you have, it can work on 8 gigs of RAM, but would recommend 16, and then a CPU that's decently powerful. And within the Besu docs in the system requirements page, there's a lot of info on what this means in depth. I don't want to spend too much time because there's also specifics for cloud environments. If you're going to use AWS or something to the like, there's info on what types of machines and more. So back to the things. The 2 new big items here are these right here. So that you're going to need in order for the engine API to work, like I just mentioned. Let me close this actually. You're going to need something called a JWT secret. So this is a JSON web token. It allows your engine API, these 2 these two Teku and Besu instances to talk to each other. This doesn't need to be hosted locally. I just put it in my local folder, wherever. And these can be generated from the command line, and very simple to generate these. The Besu docs contains the exact commands you need to generate these. It's dead simple. You don't need to like fiddle with it. Just make sure that you've generated a token and that your environments can access that token from both the Besu and the Teku side. It will need to be the same JWT tokens. So yeah, I can't comment too much on the security implications of using JWT tokens. Just don't expose these. Depending on how there's plenty of guides specifically on ETH Staker, which is a Discord community on basically securing the JWT tokens. I won't get too much in depth on that. But yeah, there are certain implications to using these. I would encourage you to read up on them. But the engine API port, the RPC, this is the command in Besu. It's slightly different depending on what client you're using, but you need to make sure that this is pointing to the same one in your Teku config. So I'll go over there in a moment, but 8551 is the default. I would recommend, if you're testing locally, just stick to the default. These obviously need to be changed depending on the environment that you're using. Port forwarding will probably be the biggest headache if you're using things like Docker and things like Kubernetes. So, make sure that you have the right ports mapped and the right ports enabled. This is probably going to give you the biggest headache when it comes to connecting two machines together if you're using containerization. That's just a word of warning. There's information in a lot of these online guides on how to make this work simply, but yeah, this is really, truly, this is the biggest change between a Besu config pre and post merge is this right here. We have named networks in Besu, so you can simply just type in the network name and it'll configure pretty much everything else for you on that part. This can be pointed to mainnet, to other test nets. We provide the specifics and we help you peer based on this. So you don't have to do anything with DNS, like as long as your machine can communicate outward, the named network should do whatever you want to do. To answer another question, we have one here. If you want to run a non-validating node like an archive node for data analysis, do you need a consensus client? The answer is yes. If you want to follow the mainnet chain, you will need a consensus client to keep your execution client can really only go up to the merge boundary without a consensus client. So in order to fully sync an archive node for mainnet, you will indeed need a consensus client there. So one thing to note, yeah, but there's also a nuance to that, is that there are consensus archive clients and there's execution archive clients, and they both mean slightly different things. If you're interested in data analysis around smart contracts and accounts, the consensus client, the execution client, excuse me, should be archived. So Besu would be an archive node if you're interested in pulling that kind of data, a historical state, all that good stuff. The archive client on the execution side, that will be more geared towards like beacon chain data. So the history of syncing or of proof of stake, all that good stuff, less geared towards kind of cool smart contract data consumption, et cetera. But yeah. So in this case, I'm using my sync mode to be snap sync. This is an experimental flag. However, the only reason that we keep that experimental is because we are not we're going to be getting rid of that in 22.10, which will be released quite soon. So don't worry about this. This is the most tried and true method. We also have a checkpoint sync. I'd recommend sticking to snap at this time. It's fast, it works, it's tried and true, and we recommend it. Data storage format in Bonsai. So Bonsai, as you might have heard, is a big kind of approach to state storage within Besu, where we provide essentially a backward-looking differential in the state. What that boils down to is you don't have to prune the node, which is quite nice. If you've run Geth or if you've run other nodes before, Bonsai provides basically implicit pruning, and it keeps your state storage from growing really out of control. So if you're trying to keep your state storage from bloating a lot, use Bonsai. We also have forest mode as another option. If you're trying to run an archive node, my suggestion is use forest. The reason being is that Bonsai will, again, it doesn't fully store all of the chain data. It's It stores kind of differentials that allow you to recreate historical state. But if you're trying to query historical state, a lot of the time, just use Forest because it uses more data, but it gets you to where you need to go without using a ton of CPU. So it's trade-offs. There's more in the docs that explains this, but you're also going to need to use full sync mode if you want to run an archive node. So full and Forest is what you're looking for. It will take a long time to sync. Just a heads up, we're looking to improve this. It could potentially take up to months depending on your latency and the speed of your machine. But to clarify what this does is that it syncs and executes every single transaction from Genesis to present. So if you're running on Ethereum mainnet, that's like millions and millions of transactions that need to be fully executed. It'll just take a long time. So if you're using that for data purposes, that's totally great. But if you're just trying to play around, and you can still get near head data this way, like when I mean near head, I mean you can still get data from the head of the block, like close to the front of the blockchain using these two options. And SnapSync also doesn't prevent you from getting historical state. So, play around with these, see what happens. There's more information on what exactly you can and cannot get when using all these modes in the docs. But yeah, that's there. Identity, you don't really need this. RPC. So these are some of the commands you need to run around your RPC. My port is 8545, like I mentioned when I was talking about MetaMask. This will need to be exposed in a way that makes sense. I don't recommend avoiding port conflicts. We have a WebSocket port exposed on 546 and a GraphQL port exposed on 547. So depending on what you're most familiar with, we offer multiple ways to interact with basically the RPC or the GraphQL. I'm recommending that if you are running on a mainnet network or if you're running in production, do not expose all of these APIs. I would recommend removing admin and debug, but you will want the rest essentially. There's tons of information in the docs, but you just don't expose admin to the broader internet. Metrics, I'll dive into what this means. Grafana, great stuff. Just it goes over in detail how your node is running, node health, all that good stuff. And then peer-to-peer hosts. I'm not going to comment too much on this. It really depends on the environment that you're using. For me, it doesn't. When I'm exposing bare metal on my machine, I have pretty much zero issues peering. That is not always the case. If you're not using UPnP, and if you have specific NAT environments and differences depending on Docker, especially, check these settings out if you're having issues with peering, because you might not be able to peer outwards and you can only accept incoming peer connections, which is often the case, which will lead to slow performance. If you have low peering performance, and I'm talking about, let's see, I have 25 peers right now because that's my max, the default max peer config. So you should be filling that up once you're in sync relatively fast. So if you're not seeing peering numbers, if you're seeing like constantly stuck at 0 or 1, check this out. Make sure you're looking at those settings. One other thing that I wanted to dive into quickly that I forgot to actually put into this config, I apologize, is eNodes. Let's see. So you can set up local networks basically where you can specify Ethereum node addresses and you can connect to those nodes. So you can kind of set up local proof of stake testnets and have your nodes communicate with each other. You need to obviously supply them with data and you need to, use specific things. But for testing, it's really kind of cool. I'm going to try to find, sorry. Yeah, here we go. Yeah, so these are the boot nodes. If you're looking to set up, this is also useful for folks just running private networks, of course. But basically, you can set your own list of eNode URLs, and I'm going to go back to my logs here. My node's eNode is Sorry, I'm trying to find it. Anyway, I think it's here. We go. This is my node's eNode. So if you wanted to hit this node from the internet, you absolutely can. I don't really care if you do. This is on Gurley. You're not going to hurt my computer or anything like that. And this eNode will also change based on if I spin up and spin down this node. But this, so you're going to get like these node addresses can be parsed in through your command line, through your config file to test local networks, to peer. For example, if you have one node that's synced up with mainnet and you only want to peer with that node, or if you're running an infrastructure environment where you have, maybe you only want to expose one node to the broader, or a handful of nodes to the broader internet, and then propagate the data from those nodes to other nodes, you can use these boot nodes to get really fine-grained control over how your peering works. It's not for everybody. I mean, if you're just running a solo rig, or if you're just running one node, you need to use the default boot nodes because you won't be able to sync otherwise. But yeah, just one thing to look at. I don't know who's would want to use this, but there are really cool stuff. There's really cool stuff that you can do with those boot nodes, and you can get kind of creative, especially if you're having those peering issues with Docker, because you can point to fully synced nodes. You can have like a snapshot node that, serves other nodes. You can get really creative there. Okay, so that was all for the Besu side. So again, I'm going to share these config files. They're in I've shared the links already in the kind of sign up page for this webinar, but I'll share them again. They're two gist links. So it really is just a copy of this, and I've changed my secrets like with other, stuff. One thing to note too is that if you're on a post-merge network, if you're having trouble peering, you can drop the minimum peers to 2 or even 1. In a post-merge network, you don't need a minimum number of peers to basically validate a head block to sync to, because that's handled by the consensus layer. Previously, the default number is 5, because in a proof of work network or a pre-merge network, you need a good sampling of nodes to understand what is the source of truth. But since we're relying on the consensus layer to determine basically the head of the blockchain, it's safe to drop this number down. So I use 2 just because it allows you to start a snap sync faster. You can keep it at the default, but if you're having trouble with peering, which really depends on your environment, check out this flag and you can often just drop it down. Okay. Any immediate questions in the chat? I'll wait 2 seconds. Awesome. Okay. Now, Taku side. This one's even easier. It's pretty great. And the log destination console, same thing. Data path, where are we looking here? The great thing about the consensus layer is due to a property called weak subjectivity, which I will absolutely not get into. You can basically sync the full network in about 2 minutes. I will run a full sync of the consensus layer while we're doing the webinar. But essentially you pull these initial states from another node in the network that has, or another endpoint that has a recent finalized state. And due to the properties of weak subjectivity, we can assume that to be the correct head, and we can go straight there and ignore the other stuff. So I 1000% recommend using a checkpoint sync, unless you're running an archive node. Why, this is for you to decide, but this is a really cool feature of the consensus layer that we're looking to bring to the execution layer. We're trying to decide how that works. Can we do a checkpoint style sync where we just pull from the consensus layer and let you sync a node in like a little bit? We have a checkpoint sync. The checkpoint, it doesn't work quite the same way. So they're not misnomer, it's just a different name. But anyway, I'm splitting hairs with this one. Use checkpoint sync. It's really cool. You sync really fast. You can copy this direct endpoint. The Ethereum Foundation provides these endpoints free and open to use. So if you go to the Ethereum Foundation website, you can find endpoints. You need to make sure that it matches your network. So if I'm on Gurley in this case, if I was on Sepolia or a different testnet, I would need to obviously swap these links out. We got a question. Is there any difference in running Besu bare metal Docker versus WSL2? That is a great question. I'm not so sure. I can follow up on that and get that back to you. I would encourage others to chime in the chat if you have experienced any differences here. My guess is that there's always nuance when it comes to the ports. Exposing ports is always weird and can be a headache. And also kind of some of the memory consumption things, Java does interesting stuff with memory and with garbage collection. So making sure that your node health is in proper shape really, it just changes depending on your environment. And there's also a lot of Java options on that can change things like heap size and, memory constraints. I would encourage you, if you're not familiar with any of those, to read up. We have some information in the docs on like some of the best Java options to change. But as for WSL2, I'm just not too familiar with that environment, so I can't really comment too much, but I've encouraged folks to chime in the chat. Okay. So we're on Gurley as well. Teku provides the specifics with the releases. You need to match these configurations 1-to-1. So the JWT secret, I'm pointing to my exact same file path as my previous one. The execution endpoint. So EE is the execution engine. Endpoint is the exact same endpoint. Again, these need to make sure that they match. The semantics are a little different. In this case, Teku is a YAML file expecting a full URL, whereas Besu is just parsing the port and doing it itself. These specifics, like I said, I'll share these, so you don't have to worry about this too much, but the documentation provides very clear instructions. Same with the JWT secret. If you're actually running a validator, you got to go here and read this validator. Basically, there's a ton of configuration options. You have to set a fee recipient or you're going to lose rewards. If you don't configure your validator properly and you're staking, your rewards go to a default address, which is like fake. It's like not a thing. And you're just losing your ETH. So make sure you at least set your validator proposer default fee recipient. This is a random address that's provided in the docs. But you want to change this to an address that you control so that you can earn your rewards. Teku will yell at you if you don't have that done. So here we go. The API is enabled, but no fee recipient has been configured. It is strongly recommended to configure to avoid possible block production failures in case the node has not been prepared to receive proposers by the validator client. That's a lot of jargon. What it means is if you don't set that up and read those documentation components, you are going to lose out. One piece of nuance to note is that a consensus layer client like Teku is actually split even more into two pieces of software. So there's the validating client and then the beacon client. So the beacon client is the one that lets you just run consensus, check the chain, do what you need to do. You do not need a validator running to connect to the network and to interact. The validator client does need to be running if you're staking in order to gain the rewards and to do some of the additional behaviors that are required of Teku to earn those rewards. So a lot of information on that in the Teku docs. It's pretty straightforward. It's basically one piece of software that acts as two, but you don't need those components if you're not validating. I would recommend just go checking that out. The nuance is actually not that crazy. It just is, if you configure your stuff correctly in the config file, then you don't have to worry about the validating client ever existing. It'll just run in the background and do what it needs to do, and it'll complain if you're doing stuff wrong. So one other thing I want to note is the Prometheus file. These are if you're familiar with Prometheus, it's a metrics collection. That's not good. It's a metrics collection engine. Besu is configured to work with Prometheus and Grafana. I see that Martin shared a Grafana link in the chat, which is great. All you need to do is copy that ID and then run it import it into Grafana and then add Prometheus as a data source, and you're up and running. This is literally a copy paste from the docs. So if you go into the docs, you copy paste. The things to keep note of are the scrape intervals, basically, your ports, obviously, and then if you want to change any of the schema around naming, then you're more than welcome to do so. Okay. Gonna pause again before I switch over to the actual nodes to talk a little bit about what they're doing. And then I'm going to start actually spinning up two new nodes. We'll talk about the nodes. We'll talk about metrics. I'm going to spin up some new nodes, and then we're going to talk about connecting to your nodes via MetaMask and using your own Besu node for RPC, which is really cool if you're worried about censorship or RPC failures. Run your own node and connect to the network yourself. That's my best advice. And use any wallet to connect to your RPC. So I did say that I was going to pause, and I didn't pause, so I'm going to pause. And if there are any questions, I'm going to take a drink. And then if not, we'll get started. Cool. I just keep them coming in the chat. I'm basically just picking those up as they come in. I cannot see the YouTube chat though. So if there's anything burning in the YouTube chat, I would ask that those someone, I don't know, somehow could get it to me. That'd be great. Cool. All right. So let's switch over to my running nodes. I'm going to make this a little bigger. Try to bear with this text. It looks crazy. But I'll walk through it really quickly to show what's going on really. So like I mentioned, once you have Besu installed and built, you really only need to point it to the configuration file that you set up. So this is the path to my config file. So, I mean, what you need to do is, this is not a real command, by the way, that's an alias that I wrote. So don't try to run go Besu. Basically just get into your Besu directory. And Besu, the directory is a little confusing, frankly, when it's built. So it's not this Besu directory. Frankly, you're just going to have to memorize this. It's Besu build install Besu again. This is if you're building from source. If you're using, I build from source because I like to test things from main. I don't recommend you do this. We provide official releases and snapshot releases. Use those releases. But if you build from source, you go here. But you need to make sure that you're in the right. You want these bin and lib files. Like this is the executable you want. This Besu one right here. So if I run bin Besu version, I should be kicked back with a version. I'm just going to do that actually just for fun. So I'm running a weird dev build. It should kick you with the normal, a version. If it can hit this, and this works correctly, then you're off to the races. I'm going to close this one out. Then all you need to do is point Besu to your config file. If you want to do everything I just mentioned from the command line, that's also possible. These can be written as command line arguments. So feel free. I don't recommend doing that. It just makes debugging things harder for us. And it makes debugging things harder for you because maybe you didn't escape a character correctly, or there's just some nonsense with your shell parser. Just use a config file. I mean, it's cool to use config files. You don't have to be too cool to use the command line. So anyway, I'm starting up with logging level as info. A lot of boilerplate, a lot of good information that you can glean from these logs initially. So of course, I'm starting my Besu version here. I don't have a static nodes file. So it just uses kind of a default one, which is basically just a list of girly nodes. But you can set this static node file yourself. And that's similar to using the kind of E nodes that I mentioned before, where if you want to pick direct nodes to peer with, you're more than welcome to do that. And that static node list will not, it's static, right? You just pick a bunch of nodes that you want to peer with, and you can check this. Yeah, so the file doesn't exist. No static connections will be created. That's fine. I want to do regular peering. No static nodes connected. It looked up a database. It found one. This is because I synced yesterday, so I wanted to make sure. It'll be version 2 if you're running Bonsai, version 1 if you're running Forest. This is relatively unimportant, but if you think that you're running Bonsai for some reason and this reads version 1, then you are not indeed running Bonsai. This is my node's public key. Also doesn't really matter. I'm trying to think what else is interesting to discuss. Yeah, starting external services. So again, my metric service is localhost 9545. My JSON RPC is localhost 8545. And that's just more of the same. I guess that's from the Vertex event loop. Yeah, JSON engine RPC 8551, GraphQL, all this good stuff. So just double check that this is in the correct order. I did not use a NAT environment, though there are options around using NAT if that's your thing. Check the docs in the options folder. And then this is where things start to get interesting. When you start the network, what this means is that you're going to be starting your peering. Your peer-to-peer agent will start listening on the default port, which is 30303. That is specified here. Don't really change this. unless you're using private networks, the Ethereum spec will provide a port, and it's 30303. So these are kind of just decided by the network. You don't really need to change it. Okay. Cool. Since I synced my node last night, I kind of went straight into real stuff. So my node is operating in proof of stake mode, which is great. I'm receiving payloads, I'm generating new payloads for blocks. So this block is number 7716953. I'm receiving these payloads from my peers. Since my node is not validating, it's not really creating new payloads right now. But I am, this block is the most recent block on Gurley. It contained 83 transactions. It had a pretty typical base fee of 30Y on Gurley, and it used 79% of the gas limit for that block. If I were to mine this block on mainnet, that would be pretty great. You want to use a bunch of gas within the block because that means as a proposer, you get more rewards. I don't suggest that you nitpick these logs and be like, how much gas did I get? How much did I get in my block today? But if you do propose a block, maybe it'd be cool to just go back and check it out and look at the info so you can see, what's going on. Totally up to you. These are pretty much the only two log lines you're going to see unless you're doing attestations and like validations. So the fork choice updated. This is your consensus layer telling you that the chain has switched to a heavier fork. And what that means is proof of stake has chosen the correct chain and we're migrating in that direction. So my execution layer client, which is Besu, is moved from this fork to, from whichever the previous head was, which was OX5EA, to OX89099. And this can be due to multiple things. This can be due to the fact that simply more blocks came in, or it can be due to the fact that there is potentially a reorganization of the blocks. Regardless, the logs that you really want to be looking at are on the Teku side for that one. But I'm going to switch over here. Again, I have 24 peers. I'm importing blocks. Not too much craziness is happening. You will see pretty much the same logs in your normal operation of Besu. When you're validating and proposing blocks, you will see new logs. Those proposal logs are not really that crazy, and they're going to happen so infrequently that I would you don't really need to pay attention, look at it. I know this is a kind of information overload, but it's unfortunately not very exciting when the node is actively running. But I'll answer questions here. If not, I'm going to go over to the Teku side, and then I'm going to talk about metrics. All right, seems not that's good. Okay, so like I mentioned, Teku doing its thing, logging to the console, talking about warnings. It was able to load the JWT secret. It was able to, well, you actually will see execution client is online. Normally this is bright green, but since my text is already green, you can kind of see it. I don't know if you can on the Zoom that it's slightly different, but Teku normally uses white text. So and Besu uses similar, don't use this green background. This is crazy. I mean, you can if you want, but this is what you need to see, right? Execution is online. I'll show you what it looks like when I spin up my new nodes when Besu is syncing, and Teku cannot really talk to it. It can, but it can't do much because it's waiting for Besu to get in sync. Like I said, the consensus layer gets into sync way, way faster. So it's normal for Teku to be waiting quite a while for Besu to be in sync. But anyway, this is what we want to see. It can connect to the execution client. These are more warnings. This is when it was syncing because like I said, I fell out of sync last night when my computer ran out of space. But I was able to get back in sync pretty fast, actually. I only had 9 slots. And for those that don't know, a slot is essentially a block to be. They're now called slots because there's potential for empty slots. But essentially a slot is somewhere where a block could go. If you are familiar with slot, they're incrementing by 1. It's very straightforward. Every 32 slots, there's an epoch event. And these are basically more proof of stake nuance. There's tons of explainers on what this actually means. In reality, it's just a way for the network to achieve additional finality across the boundary of these epochs. So what it means is we're running those 32 slots. When we have enough of the epochs done, we can justify the epochs. When those epochs are justified, we can then finalize the previous epochs. So everyone votes, everyone chats, we agree on the chain. Once we finalize blocks, then those are, they're considered out of the reorganization depth. So we can't reorg those blocks. They're good in the chain. And that's one of the other key things about proof of stake is that we can finalize blocks a lot faster than in proof of work, because the chance for a reorg is a lot different and less in certain instances. So we get justified epochs. Economic finality is what they call it. Okay. Let's see here. What else is interesting? Yep. Epochs again. Lots of slots. Epochs again. Pretty boring Teku logs today, actually. This is one interesting one. There was a regeneration event. What I believe, I don't actually want to comment too much on this because I only have a cursory understanding, but I believe this signals some kind of reorg around 4988. However, this was the first block that I resynced when my node started back up. So there potentially was just the fact that the execution layer was not online and it had to wait to replay that block. Pretty sure that's what that is. But you can get some logs like this around reorgs and things. Okay. Besu running, all good. Teku running, all good. Postman, I can, got to set these up before. Like I mentioned, this is just APIs. I can hit my Besu node and get some data. There's my E node. This is really small. I'm positive this is really small. This is the primary way that I use to interact with the RPC. You can do whatever you would like. But tons of good information in here. They're not exclusive to proof of stake. Like these are for click consensus algorithm stuff. These are for debug specifically. Just to remember, if you have these APIs map to your config file. So if I have these enabled, then I can, oops. So it's like, these are the ones that I have enabled. It means I can hit any of those, I can't necessarily hit these endpoints. Well, yeah, method not enabled. There we go. So really good stuff here. Like, admin is useful for debugging issues. I can check all my peers, what they look like. So I have a Geth peer here, another Geth peer, just Nethermind peer, all good stuff, right? Check that out, yada, yada, yada. This collection is available from the wiki. You just download a JSON file, you import it, dead simple. It's all in the docs. I'm not going to spend too much time on that. Next thing I want to discuss is metrics. So Prometheus is the primary data source. I know this is my old terminal. Basically, all you need to run is brew, install. Like if you're using Homebrew, there's other ways to use Prometheus. I did Homebrew. It's just easy to test. Start Prometheus in the background. Fine. Same thing with Grafana. I use brew again. Brew service start, Grafana, yada, yada, yada. This is Prometheus. It's not the interesting graph, but you can add a whole mess of, there's a ton of metrics. Yeah. Block gas limit of the current chain head. It'll give you like little things on what they actually mean. So if you're looking to do kind of unique metrics approaches, again, I'm not going to spend too much time getting on this, but there's so much good stuff in here. And then once you've added them into Prometheus, you can check over in Grafana and you can add them as new, like you can add more panels to match what that is. So this is part of the default dashboard that we provide, the Besu overview dashboard. It provides my endpoints, the current chain height, target chain height. I'm no blocks behind, which is great. You don't want to be blocks behind. If your block's behind, it means your node is stalling for some reason. It might be either starved for resources, or it got stuck somewhere, or there's an issue. So you want to be as close to head as you can. Time since last block, 23 seconds. That actually doesn't make sense, but I'm thinking that is an issue, is an error of not refreshing. Interesting. Because the average block time is 12.39 seconds. So yeah, we must be on the boundary of a slot, and I'm just silly. Anyway, 100% of my peer limit is used. That's good. Healthy amount of peers, 96%. What have you. So this is kind of a misnomer. This is a 5-minute average. The block time in proof of stake is set exactly at 12 seconds. So this really shouldn't fluctuate. I'm not quite sure why it is fluctuating. It might be a girly weirdness. Girly does some weird things. So as I mentioned, to import this dashboard, you just go to import, and then you type in the URL from the docs. So that's the Grafana one that was shared in the chat. And then it has really good things. If your node is in sync, this panel is useful. It's around fasting progress. When I'm syncing the other node, I'll come back and I'll show you what this looks like. We love to see this 0 blocks behind. Block time is super weird. Yeah, this must be a girly thing, unfortunately. I don't know why it's not 12 seconds stable, but anyway. Yeah, CPU utilization. There's going to be peaks and valleys depending on what you're doing. This is actually quite low. I'm very excited about that as well. The memory is also super low. Do not expect this on mainnet. This is not to be. Mainnet is much more resource intensive. Like I said, you can expect this RAM number to creep up much, much higher. So don't use these as a representative sample. I've also done no garbage collection, which is also not representative on mainnet. But definitely make sure to test your staking, test mostly your configuration on Girly, but test you got to make sure that your hardware is ready on mainnet. I would recommend running a non-validating node on mainnet for a while and seeing how it reacts before you actually provide any stake. Okay. So Prometheus and Grafana, gross oversimplification of what they actually do. They're super powerful tools. And all this information is in the docs. There's tons of stuff. There's Java stuff, which is also really good too, if you're trying to debug Java stuff, but most of this is for us to make sure that we can properly debug Besu. Trying to decide where I want to go next. Okay. Switching back over to here. So again, I'm going to pause again and see if there are any questions. I want to again show that we have these great nodes running in the background. Cool. So in my browser, I'm over in my MetaMask here. This is a account that is just, we have a consensus. I have a lot of Girly ETH. But this is the interesting part, right? I'm currently looking at localhost 8545. If you remember what I put in my configuration, my RPC API is at 8545. So I'm connected directly to my Besu node via the RPC in MetaMask. So you can run your wallet like this all the time. MetaMask holds the keys and it exchanges the stuff via RPC on its own. So I can, I can have my ETH and eat it too. I don't need to worry about the wallet here, but I can run my RPC commands through my own Besu node, which is pretty great. If I go to my settings, one thing to note here, you have to make sure if you are connecting to, I clicked the wrong one. So this is my localhost again, this is the localhost port. Make sure the chain ID matches your network. So Girly is chain ID number 5. This might not default to number 5 because it doesn't know what network you want to start with, or what network your local node is connected to. So just make sure your chain ID matches the network. You can go to chain list. Chain list will tell you, for example, Arbitrum, great. 42161 is the chain ID. These are just random numbers. So you got to just go look it up, whatever you're trying to test. If my node was synced to mainnet, I could put my chain ID as 1 and I can go off to the races and, use my own node as RPC. But anyway, Make sure the chain ID matches the node that your Besu is synced to. I'm just going to get out of this screen right now. But yeah, so like I said, I can see this balance. I can send ETH to whomever. I guess I'll transfer it to myself, like 1 ETH. And I can run it through the network, and it will, my Besu node will put it up. Oops. Cool, it worked. So I sent myself an ETH, but I did it using my own node. That might not seem that cool to everybody, but if you know how wallet software works, that's not really the case in most circumstances. It's plugged to a public RPC endpoint, but in this case, I'm running it myself. I'm putting my own transaction into the mempool of Gurley, and then other nodes are executing those transactions via proof of stake. But my node propagates that transaction. So that's really kind of, it's, you know, exciting stuff, right? That's the, like I said, it doesn't sound exciting on its head, but it's pretty cool that you get to run your own node and you can do your own RPC if you want to be even more decentralized than just base MetaMask. So I sent that ETH over. It is in my account. I'm not going to pull up my other account because that's my other account. But let me go to an app. We're going to go to SushiSwap here. It says unsupported network. In theory, it is. You don't really need to be sushi swapping on Gurley, but you can. Let's see if it'll give me anything back. I think the answer is no. So again, I'm interacting with the dApp here. I'm localhost 8545. It's giving access to Bento Box to move the funds. I'm going to sign this transaction. I don't really think it's going to do anything because I don't know how Sushi works on Gurley. Okay, well, anyway, you can connect. So if you have a dApp that is connected to whatever network your Besu node is on, so if you're running a consortium network and you want to do, you know, RPC there, sure, it works. If you're developing a dApp and you deployed that contract to Gurley, you can also run it this way. So that's an easy way to not have to use public RPC to test your stuff. You can also, like, yeah, there's a number of things that make this useful, mostly from a smart contract development perspective. But regardless, it works, right? I can connect to a dApp on my local RPC node and do whatever I want. Whether it works, it depends on if the dApp supports Gurley or not, which in this case, it seems like Sushi does not. But that's cool. A lot of things do support Gurley. Whatever, doesn't matter. So that was pretty much it on the wallet front. There's a lot of, like I said, it mostly applies to developing things with either private smart contracts or public smart contracts. So I'm going to quickly switch. I'm actually going to go here first, you know, talk about Truffle smart contract development. You know, this is a smart contract development framework. There's others like Hardhat and, you know, a variety of things. Truffle works with VS Code and all that good stuff. I'll just drop the link. I won't really plug it too much. Besu GitHub repo, cool, check it out. Open issues if you find bugs, or contribute code if you want to get paid and do cool stuff and work with our teams. There's also the Hyperledger Discord and the Consensus Discord. So if you have questions about things like MetaMask or other stuff, the Consensus Discord has you. We have Besu channels there, but we also have Besu channels in the Hyperledger Discord. So just more options. Really quick, I want to step back, talk about what it looks like if your node is already staking. Beacon Chain will keep track of what you're doing. Oh, sorry, do you have a question? Or just someone not on mute? All right, I think it was the latter. No worries. So Beacon Chain, great resource. Once you have your stuff, like this is a random validator that I picked from Rocket Pool running Besu. Very effective validator. 100% of the block proposals were included in the network. Love to see it. 99% of attestations. Also love to see that. That's really good. No slashing, whatever. This is a really great resource because you can, again, you can check the status of your stake at any given time. You can also set up alerts. So if your validator goes down for some reason, Beacon Chain will send you an email to like check it out. So these are the states, right? You deposit your ETH into the smart contract, the deposit contract, you wait for it to get activated, your validator becomes activated, and then you get a whole bunch of stats. So in this case, I'm actually going to go directly to the validator. We can see that the validator proposed a block on what day? Yeah, that was yesterday. That's why so if you look back at why is the income so much higher on this one day? The reason being is that they proposed the block on that day and you get a lot more rewards for proposing a block. So they got 0.03 ETH just for that block proposal. That is about, I don't want to do math, but it's, it's 3% of like $1,400, $1,300. So that's a good bit for one block proposal. This number, I can go much higher depending on how much space in that block is used, how much tip is included, et cetera, et cetera. We can check again, not to bully this validator, but they've earned 0.1 ETH in about a month. So that's, $100. This is one validator. This is actually kind of low. As you can see, this validator is in 47,000th place, which is maybe not so great. This validator, though, if we're looking out, has really absolutely crushed it. 35 ETH. That's pretty cool. Since active since okay, over 2 years. So that makes sense. But they've made 3.5 ETH on just one validator. So, the numbers, as I said, it depends on the amount of staked ETH you have and the amount of blocks you propose. But, Beacon Chain is a good resource to check in on once you have your validators up and running. If it supports Gurley, I don't know. That's a good question that I'm thinking of right now. I'd be curious to see if you can check on your Gurley validators this way. I don't think so. Well, I don't know. I only have looked at my Gurley validators on my local machine. Anyway, I will switch back to here. Yes. To answer the question, are the webinar docs public? Can we access? Yes, absolutely. I will share the slides immediately following this webinar. I've pretty much wrapped up the content. So we have 20 more minutes, can do totally random question hour. We can talk about the content, which is what I would love to do, but I am more than happy to answer general Besu questions, or just general Ethereum public network questions, or even potentially other random questions. So whatever you have, I'll give a couple minutes for folks to fire away. If not, we will end a little bit early and I can give you your time back. And then as David mentioned, he'll be sharing the slides, sharing the recording. So the recording will be made available. And when the YouTube links for Global Forum are ready, I'm presuming they will also be shared to the same group. Like I said, if you have questions about the future of Besu as an execution client, go check that out. I answer a lot of those in that webinar, or it's not really in that talk that we were giving at Global Forum. Questions? And if no questions, that's totally cool. I'm going to actually bring it up to here so that folks can see my email one last time. Do we plan to do a standalone session on how to start contributing to the project? David, I think we absolutely should do that.
Great idea. Yeah.
Yeah, we absolutely can. I have been meaning to do that for kind of quite a while. I want to be able to pull together information on protocol guilds to give people an understanding of what they actually get if they contribute to mainnet stuff. But truly any and all Java developers can just go into the code base. We've tagged things with good first issue. So good first issue label, that's a good first issue. And we have a pretty robust maintainer community to work with you. So if you open PRs, then we can review them and you can get rewarded if they're directly related to mainnet stuff. So that is that. Did you need to configure Teku to connect to the ETH2 network? Yes, we did need to configure Teku. We talked about it in the kind of middle of the session. I will share, again, I'll share my configuration files in that they're in the webinar open, like the first page thing. I don't know what it's called again, but like the opening page kind of. But yeah, there is also going to be a recording, and there's tons of information in that part about how to configure Teku, but it's very straightforward. Contributions from non-Java developers. That is a good question. Our code base is like 98% Java. I'm trying to think how we could work on that. That's something that I'm going to take note of actually for the session, David. I'm going to take a note on like how can we bring in non-Java developers.
It's a good question for sure.
But yes, like any developers, we'd love to get involved. Non-Java devs, I will think of something on that one. Does Hyperledger have any tools that help with KYC if US lawmakers crack down? That is an excellent question. The answer, I would say from the Besu side is no. We're exploring how to best support these regulatory frameworks at the protocol level. What that means is, if regulators do decide to move more and more towards kind of whitelisting in certain things, that Besu might, I'm not agreeing to anything at this point in time, we might have to support those kinds of allow lists depending on where you're living or where you're running. But we would support like multiple flavors of Besu. Since it's a decentralized network, user choice is paramount. So if you want to use kind of like a US friendly one, then maybe we provide that. If you want to use a non, like something else. But again, I think that there's a lot of discussion around this just for Ethereum as a whole. So there'll be more to share on the future. Right now, we don't have any specific tools for this. However, there are tools already out there that can basically connect with your Besu instance that'll allow you to relay your transactions through what are being called regulatory friendly block relayers. So there are ways around this for now, but nothing concrete to share about Besu protocol level support for basically censoring or KYC. Is Rocket Pool a good way to stake one's ETH and earn rewards? Yes, we are very much a big proponent of Rocket Pool. The Besu team works directly with the Rocket Pool team. We make sure that our client works well with Rocket Pool smart node software and with the hardware that they recommend. So yes, definitely recommend Rocket Pool. I love the liquid staking approach where you can provide some ETH and still get involved. If you're not familiar with Rocket Pool, it essentially allows you to stake with less than the 32 ETH amount. And if you want to host your own node, it's typically around 16 ETH, but I think there are changes to the way that that's working with Rocket Pool ETH. It's R-ETH is what it's called. But yes, Rocket Pool is a good way to stake one's ETH. There are plenty of other ways to get involved. But Rocket Pool, the Besu team, we do work with Rocket Pool to keep everything, hopefully, in good order. Basic requirements to run in Windows 10. I would suggest Java 17 and appropriate memory. Like I said, around a terabyte of memory in your disk and at least 16 gigs on the memory side or the RAM side. With Windows, since you don't necessarily have all of the native crypto libraries that we use. So like the cryptographic operations might be a smidge less optimal than the native versions. We are working on this, but we don't have any timeline yet. You will possibly need a beefier CPU, but we recommend anything with 2 to 4 cores and decent power in the last, however many years is typically fine. The bottlenecks really depend. So you have to go, once you've run Besu on your machine to see the best about what's going on, what's my effectiveness, is check out these dashboards. If your CPU time is maxed out the entire time, if your IO is maxed out, these are not the only metrics. So add metrics around memory. So memory, add metrics around IO and disk. If your IO is constrained, you might need a faster drive. We don't recommend slow storage. We recommend NVMe. That's pretty much the same for all these kind of blockchain clients. You're going to need relatively fast SSDs. So like network attached storage is iffy. And if you're using things like AWS or cloud services, you'll want the NVMe SSD or better. Because IO contention can be, I mean, it's doing when you're, especially during a sync, IO is very important, as well as bandwidth. So just make sure that when you test things out on Goerli, you're looking at, you're looking through what your Grafana is saying and you're checking to see where there are hotspots. To the question, are there any public-private teams working on KYC or regulatory frameworks for the Ethereum network? I would say yes. I would check. The Enterprise Ethereum Alliance might be one that would be good to look into, see if they have anything. I think more and more teams will provide guidance as we go forward, as we understand what the regulators are actually looking to do. Right now, there's kind of no official stance of like Besu or Hyperledger or anything like that around what this is, but I'm sure there will be more to come. But frankly, I think a lot of the KYC will come from like client side or like front end applications where you access the blockchain through kind of a federated thing. That's my own opinion. I don't really know that that's necessarily the best or most robust answer, but there is more coming on that. So I have a question around what is the suggested operating system and processors. I suggest Linux or anything Unix based, just off the cuff, because it's easier. To like I said, we have more native libraries for Linux and Unix based systems, and the native libraries, what that really boils down to is faster performance around cryptography. And the problem is Windows at this point in time, though, again, we are working on not fixing, it's not really a problem. We're working on getting better improved support for the cryptographic libraries in Windows. But I would suggest Linux or a Unix-based system, or, I'm running on Mac OS right now. Mac OS works fine if that's your preference. Like I said, I did everything bare metal. So if you have an old Mac lying around that has, again, the memory and CPU are going to be kind of the constraints. As for the specific CPUs, I wouldn't use anything that's more than like, it really comes down to, I'm trying to think about how to best phrase this. Like specific threaded performance is useful. So having like 2 to 4 cores is definitely valuable. Java will make use of a lot of the space that you give it. Let's see what my CPU is doing right now. Yeah, so Java's actually, it's pretty happy right now because I'm not running a sync. So it's not using very much. So one of these is the Teku process and one of these is the Besu process. I'm not quite sure which is which. But regardless, it fluctuates. And during a sync, this can go as high as 300%, which means it's using like 3 full hardware threads to run one instance of Java. So it's mostly during sync that you'll see. I'm going to share, there's a place in the docs that talks about like CPU profiling. This is the page that I'm going to share. This will give you a ton of information on that exact question. Like, what is the CPU? Like, I don't know. What's the best way to look at CPU, to understand Grafana, to understand CPU usage within Besu? Because again, you start off really high. You get, as you sync things and import blocks, you reduce your CPU usage. So if you have an older CPU, your sync might take longer, but you might be totally fine to run in normal operations. So at the end of the day, it's not really a big deal, right? Because you have to sync once. Like you sync once and then your CPU is running. So it's kind of like, okay, it sucks that it's taking longer, but once I'm caught up to the head of the chain, it doesn't matter as much. So I would read this page that I just shared. I'll put this somewhere in the slides too. Anyway, let's see. Any specific distros on Linux? I don't really know. Whatever you're comfortable with. I mean, they all kind of run systemd, so it doesn't really matter. Whatever you're familiar with. Regulators can make the use for soul-bound tokens, or will be there a better way, like the federated or high-level way to KYC? I think that that's a better question for the DID groups at Hyperledger. I'll let David plug those if he wants. There's like a bunch of decentralized identity working groups at Hyperledger. As to if soul-bound tokens are, fit into that DID framework that is KYC'd and all good and dandy, I don't know. I think it's a little early to know, but it could be a good use case for that. We'll have to see. It also depends on what the people are trying to do, right? Within the network, because not everything needs to be KYC'd, only certain things, and like read-only access versus read-write. If I'm putting data on the chain, do I need to be KYC'd? If I'm just reading information, yeah, David shared a link about the identity working group. I would definitely look there for details. I don't know if they touch much on soul-bound tokens, but that's probably a good place to start. And you can probably apply soul-bound tokens to a lot of the concepts that are relating to the same DIDs and like credentials in the other working group. I'm gonna stop my screen share here. Yeah, it's not so great that we have to figure this all out, but hopefully we come to a good agreement at some point. Any other questions, folks? All right, I'm going to share my screen again because the Girly transaction did go through on Etherscan. So we're so I swapped some tokens on SushiSwap on Girly. All well and good, very exciting. No, not sharing again. Cool. I think that this is a good point to wrap up. To reiterate, we will be sending the slides, and I will include a lot of the links that were mentioned. Feel free to shoot me an email or message me on Discord if you have any additional questions. I'm going to actually, that's a good idea, is to go through the Discord right now to show where some of the things that we discussed today are mentioned. So let me go back to the Zoom really quickly. Just one last moment, bear with us, and then I'll let you all go. So we have multiple Besu channels. This is the Hyperledger Foundation Discord. The link is in my slides. So the ones you are interested in are obviously the Besu one and some of these other great projects, of course. And there's the identity stuff is in here as well. But anyway, Besu channel. This is just our typical channel for whatever. The Besu nodes channel is about specifically running like staking nodes. So if you have questions about staking, check out here. The contributors channel is mostly for contributors. If you have questions about getting started to contribute, you can check here, but otherwise, please don't spam too much in this channel. And then the announcements channel is where we'll have major announcements. On the consensus side, it's basically the same. We have a Besu channel where you can ask questions. And if you're having issues with MetaMask, or if you decide to use Truffle, like I've mentioned, there's Discord channels for those too. Cool. All right, I think, David, we're good to wrap up here with the recording and the YouTube. So thank you everyone very much.
Yeah, thank you, Matt, and thank you, everyone. And as Matt said, I'll be following up with some of those links and resources. So thanks for your time, everyone.